Hello students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is solving quadratic inequalities using the algebraic method. This is the second session. This is part 2. We have had the first session before. So let's start with our today's session. Stay tuned till the end. I'll be giving you the rules and I'll be explaining you the rules, taking up a particular example. So first of all, let us see that example. Let us look at that example. It is 4x square minus 11x plus 6 is less than or equal to 0, and we have to solve this quadratic inequality. It is a quadratic inequality because the highest power of x is 2, and we have to solve this to get the solution set of x. So let's come to the rules part. The first rule says bring all the terms to one side of the inequality sign, the other side should have a 0. But for this particular question, all the terms are on one side of the inequality side, the other side is having a 0. So we do not have to do anything more to this to follow the first rule. The second rule says factorize the expression. So we will be factorizing the expression using the Middleton splitting method. This is x minus 2 times 4x minus 3 is less than or equal to 0. We are having two linear factors and the product is either equal to 0 or less than 0, means either it is equal to 0 or it is a negative number. Okay. Rule number 3, if the question contains a less than or equal to, this time we are having the less than or equal to. In part 1 we had greater than. This is the difference between part 1 and part 2. In part 1 we have dealt with greater than part, and this time it is the less than or equal to. Okay. If we have a less than sign or less than or equal to sign, then one of the linear factors will be greater than or equal to, and the other will be less than. Why is it so? Suppose we have a negative number as a product. If it is a 0, it may be equal to 0 as well. Fine. If it is a 0, we know how to solve. Either x minus 2 will be equal to 0 or 4x minus 3 will be equal to 0. But I am talking about a negative product. Suppose we are having the product as negative 10. So how can we have a negative 10 as the product? We may have 2 and negative 5 multiplied together. If 2 and negative 5 multiplied together, we get a negative 10 as the product. Or else if we multiply negative 2 with positive 5, even then we get a negative 10 as the product. So one is a positive number and the other is a negative number. If you multiply 2 with 5, both are positive number, we get a positive product, that is positive 10. Or if we multiply two negative numbers, negative 2 with negative 5, even then we get a positive 10, not a negative 10 as the product. So in order to get a negative number as the product, one number should be a positive number and the other number should be a negative number. Okay, that is what is said in this rule number 4. So either x minus 2 will be greater than 0 and 4x minus 3 will be less than or equal to. Now in this case we are having this equality sign. So with which linear factor should we be including this equality sign? I have included this equality sign with the 4x minus 3 part, and for or part you are having two further subdivisions. X minus 2 is less than 0 and 4x minus 3 is greater than or equal to 0. Or subpart B is x minus 2 is less than or equal to 0. You see the two subparts are differing by the placement of this equality sign. For the subpart A, the equality sign is attached with this 4x minus 3, and subpart B has the inequality sign attached to x minus 2. This is the only difference between these two subparts. Now you may ask me that if you are having these two subparts for OR part, why aren't you having two further subparts for the either part as well? It is a perfectly valid question, and you will be knowing the answer very soon. Why haven't I taken the two subparts for the either part? Okay, but before that, let us look at rule number 4. Solve the two factors separately for both the cases, that is either and or, and take one equality that satisfies both the inequalities. I have written take one inequality, and I have written this if possible part also. So it is not always possible to take one inequality to represent both the inequalities from each case to form the final answer. But there is this if possible clause. Okay. So first of all, we come to the either part. If x minus 2 is greater than 0, this gives us the x value as x is greater than 2. And 4x minus 3 is less than or equal to 0 means x is less than or equal to 3 over 4. So x will be a number which will be greater than 2, and x is simultaneously that number which is less than or equal to 3 over 4. It may be 3 over 4 or it may be less than 3 over 4. Can you think of any number which is equal to or less than 3 over 4 but is greater than 2? X can be equal to 3 over 4, but 3 over 4 is definitely not greater than 2. X can be any number less than 3 over 4. If I take x equal to 0, 0 is less than 3 over 4. If I take x equal to 1, 1 is less than 1 is not less than 3 over 4, negative 1 is less than 3 over 4, but negative 1 is not greater than 2. So we cannot think of any number which is less than 3 over 4 but is greater than 2. Negative 1, negative 2, all negative numbers are less than 3 over 4, but they are not greater than 2. Okay? So that means we cannot have any number which will be satisfying these two inequalities simultaneously. That is why we cannot take this either subpart. So now you should be able to understand why have I not taken the further two subdivisions. It doesn't matter with which subpart am I attaching this equality sign. I cannot take this option rather, because I cannot think of any number which will be simultaneously satisfying both these inequalities. So we come to the or subpart. Subpart A, x minus 2 is less than 0, that means x is less than 2, and this one gives us x is greater than or equal to 3 over 4. Now from these two inequalities, x is greater than or equal to 3 over 4, but x is less than 2. Can you think of any number which may be the value of x and which will be greater than or equal to 3 over 4 but will be less than 2? Yes, of course, 3 over 4 is equal to 3 over 4 and 3 over 4 is less than 2. X equal to 1, if we take x equals 1, 1 is greater than 3 over 4 and 1 is less than 2. So we may have some numbers which will be greater than or equal to 3 over 4 but will be less than 2. But we cannot take, in this case, we cannot take a single inequality which will be representing both the inequalities. That is not possible. So that is why I have written this if possible part. Okay, sometimes it is not possible to take a single inequality to represent both the inequalities. In part 1, we have seen that we could select a single inequality to represent both the inequalities, but now in part 2, you are seeing that is not possible every time. And it is not possible to take a particular inequality or a single inequality from both the cases, either and or. Okay. So in this case, the subpart A, we will be having an interval, a set of values. for x which will be satisfying these two inequalities. So it is x is greater than or equal to 3 over 4 but is less than 2. Subpart B says x is less than or equal to 2 but x is greater than 3 over 4. So this is also giving us another interval. The numbers are the same but the equality sign placement is different. So as the final answer, we have to combine both of these two inequalities. So we combine these two and we are having the equality sign attached to 3 over 4 from subpart A and the equality sign attached to 2 from subpart B. This is our final answer. X is greater than or equal to 3 over 4 but is less than or equal to 2. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.